To share the result, we will be flying into the heart of the galaxy, some 27,000 light years away from us. We will do that in 45 seconds. That's a violation of Einstein right away, but maybe that's probably the only violation of Einstein. So we start out from the plains of Chile, where the ALMA telescope is located. And we're going to zoom in to Sagittarius, the Archer, which is high in the sky above the, northern Chile. And we will go and zoom in first in the optical, but we have to switch to the infrared because there we can penetrate all the way into the galaxy. We leave tens of millions of stars behind, and we get to the place where stars are in orbit around a dark spot. And when we switch then to our radio eyes and we use a network of telescopes to resolve further and further, I can present to you the image of Sagittarius star, the black hole at the galactic center.
This is the first image of the supermassive black hole at the heart of our Milky Way galaxy, Sagittarius A star. For decades, we have known about a compact object that is at the heart of our galaxy that is 4 million times more massive than our sun. Today, right this moment, we have direct evidence that this object is a black hole. The black hole resides inside the dark region at the center of this image, where its gravitational pull is so strong the light cannot escape and only darkness remains. We call this region the shadow of the black hole. This region is surrounded by very hot gas swirling around the black hole. This gas emits radio waves we observe with the Event Horizon Telescope. These radio waves create the glow we observe around the shadow of the black hole. From our image, we measure the size of the shadow of Sagittarius A star to be 52 micro-arcseconds on the sky. This is about the size of a donut on the surface of the moon as seen from Earth. In reality, Sagittarius A star is about as big as the orbit of Mercury around the sun, but at a distance of 27,000 light years. Because the size of a black hole shadow is proportional to its mass, our image tells us that the mass of Sagittarius A star is 4 million times greater than that of our sun. It is really incredible that this prediction from Einstein's theory of general relativity matches the mass measured by the Nobel Prize-winning studies of stellar orbits in our galactic center. Today's image might look familiar to some of you. We were all amazed that the image of Sagittarius A star looked so similar to that of the famous black hole in the M87 galaxy, an image our team revealed back in 2019. However, Sagittarius A star is over 1,000 times less massive than M87 star. If Sagittarius A star were the size of this donut right here, tiny, M87 star would be the size of the Allianz Arena, the Munich football stadium just a few kilometers from where we are today. On top of that, Sagittarius A star consumes gas at a much slower rate than M87 star. And these two black holes also reside in completely different environments. Sagittarius A star resides at the center of our small spiral galaxy, whereas M87 star resides at the center of a giant elliptical galaxy and ejects a powerful jet of plasma. Despite all these differences, the images of these two black holes look very similar. Why is that? This similarity reveals to us a key aspect of black holes. No matter their size or the environment they live in, once you arrive at the edge of a black hole, gravity takes over. The journey to the edge of Sagittarius A star spanned decades of technical and scientific developments. And I will pass it on to my colleague Thomas to tell you all about our adventure. Thank you very much.